Hello everyone, myself Mrs. Archana Matre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the fourth unit of Basic Electronics, that is Field Effect Transistor. So here in this video, we will see about enhancement type MOSFET. First, we'll see N-channel E MOSFET. The other type of MOSFET is called as enhancement MOSFET, can be classified as N-channel MOSFET and P-channel MOSFET. So this is the construction diagram of the N-channel E MOSFET. So here you can see the channel type is N type of material and P type of material is of substrate. The basic construction of an N-channel enhancement type MOSFET is shown in figure. A slab of P-type semiconductor, that is silicon, is used as a substrate. The substrate is sometimes connected to the source or it is brought out as a fourth terminal. The drain and source terminal are connected N-type doped region through the metallic contacts, but most important point to be noted is that the channel is absent over here. The insulating SiO2 layer is present similar to depletion MOSFET, which isolates the gate terminal from substrate. Thus, the construction is very similar to that of the depletion type MOSFET, but the channel is not present. Working of N-channel E MOSFET. The operation can be explained with two different operating conditions. First, operation with VGS is equal to 0 volt. If VGS is equal to 0 volt and a positive voltage is applied between its drain and source, that is positive VDS, then due to the absence of N-type channel, a zero drain current will result. This is exactly opposite to what happens in the depletion type MOSFET, where ID is equal to IDSS at VGS is equal to 0. Now, working of N-channel E MOSFET. The operation when VGS is positive. Refer the figure where both VGS and VDS are positive. Here you can see this is the VDS and VGS. Both the voltages are positive voltages. The positive potential at the gate terminal will repel the hole present in the N-type substrate as shown in figure. This results in creation of depletion region near the SiO2 insulating layer, but the minority carriers, that is the electrons in the P-type substrate, will be attracted towards the positive gate terminal and gather near the surface of SiO2. As we increase the positive VGS, the number of electrons gathering near the SiO2 layer will increase. The electron concentration near SiO2 layer increases to such an extent that it creates an induced N-channel which connects the N-type doped region. Now, working of N-channel MOSFET when effect of increase in the drain to source voltage. Now, in the figure, the positive gate to source voltage VGS is kept constant. At the drain to source voltage VGS is increased gradually. Due to this, the gate terminal becomes less and less positive with respect to drain terminal. So, less number of electrons are attracted towards gate terminal and the induced channel becomes narrow as shown in figure. Eventually, the channel width will be reduced at the point of pinch off, that is, it remains constant, and the saturation region will be the region which is the same as that in a JFET or depletion type MOSFET. That means any further increase in VDS at the fixed value of VGS will not affect the value of ID unless breakdown takes place. Now, P-channel E MOSFET. This is a diagram, construction diagram for P-channel E MOSFET. Here you can see substrate is of N-type material and the channel is of P-type material. Now, these are the symbol of enhancement MOSFET, N-channel MOSFET and P-channel enhancement MOSFET. Now these are the symbols of enhancement MOSFET and depletion MOSFET. So these are the symbol of P-N channel MOSFET, enhancement type and depletion type, and these are the symbol of P-channel MOSFET, enhancement type and depletion type. Now these are the characteristics of MOSFET. Here you can see these are the transfer characteristic and input characteristic of MOSFET. Here on x-axis, for output characteristic, on x-axis VDS, that is voltage from drain to source, and on y-axis ID current is there. Then when VGS is reduced to pinch off, then ID is equal to 0 milliampere. For positive value of VGS, the positive gate will draw additional electrons, that is free carriers, from the P-type substrate, and hence ID will be increases. Now advantages of MOSFET: very high input resistance, it has very low gate current required, better thermal stability, small size, low thermal noise. Application of MOSFET. Application of E-MOSFETs are: E-MOSFET can be used as a linear amplifier, as an inverter in the digital circuit. The E-MOSFETs are used. And D-MOSFET, that is depletion MOSFET, can be used as an amplifier. It can be used as a switch. Now here it is a comparison between the E-MOSFET and D-MOSFET. First point, in E-MOSFET, insulating oxide layer is present between gate and substrate. Channel is absent. At the operation, induced channel get created. D-MOSFET, an insulating oxide layer is present between gate and channel, and or P-type channel is present. E-MOSFET, for the N-channel E-MOSFET, VGS will be only positive. For an N-channel D-MOSFET, the VGS can be negative for depletion mode and positive for enhancement mode. For an N-channel E-MOSFET, ID increases as VGS becomes more and more positive, and for N-channel D-MOSFET, ID decreased as VGS becomes more and more negative. For an N-channel E-MOSFET, ID is equal to 0 for VGS is less than equal to VT, and for N-channel D-MOSFET, ID is equal to 0 for mod of VGS is greater than equal to VP. And fifth point is the symbol for N-channel and P-channel E-MOSFET, as well as symbol of N-channel and P-channel D-MOSFET. Thank you.